Hello everyone, and this is day 2 of logs. We already did this part on the smartboard. I just wanted to make sure you had it. So if you need to, pause this and copy anything down that you have. One of the things that we finished up with was, how do you find the inverse? And so right here we switched x and y, solved, and the next goal is to solve for y, but how do we do that? Well, we notice that y is in the exponent, and therefore we need to use the logs. And so defining a logarithmic function right here, it states that, well, what we already know is that the b is still a base here, that the logs give you the exponent, so therefore b to the y, and then x is the answer. With that being said, how do we find the inverse? Well, let's look here. If we find the inverse, we need to use logs. So we know that y equals log base 10 of x. And we know that's not how we finish writing the inverse. We finish writing the inverse as f inverse of x equals log 10 of x. And so that's the idea of that. Let's go to page 8. So on page 8, the first thing states is find the inverse of the following functions. So again, this is your y, this is your x. We need to switch that. And so we're going to get x equals 5 to the y. We need to make this the answer, the exponent, so therefore we're going to get y equals, that's our exponent, log base 5 of x, and so we're going to rewrite it as f inverse of x equals log base 5 of x. I want you to pause the video and try b. And so you'll notice with b that we switched x and y here. You need to get rid of logs, so you put it in the exponential form. 4 to the x equals y, and then switched it into f inverse of x. So next one, convert into logarithmic form. So exponent is what logs give you. So x equals log, what is our base? Our base is 10 of y. Let's try it with that one, and then you guys are going to try C on your own. The exponent, 4, equals the log of base, that's the 2 of 16. You guys are going to try C on your own. So the next part says to switch the other way around. So again, this is the exponent, your base, so 6 to the y equals x, and 4 to the 5 halves equals 32. I hope it's starting to make sense. Base, that is your exponent. The log gives you the exponent. So what I would like you guys to do right now is try to do A, B, C, and D, and see if you can get those correct. Pause it, and then when you unpause it, I'll have the answers. With that being said, one thing is that you're trying to evaluate it, so you are trying to figure out what that equals. So I'm going to write x's equals x for all of those. Hopefully that makes it easier for you then to figure out what x is. Alright, pause it now and then do it. So I hope you guys got to this part. And I know that some of you are probably going to be a little confused here, so I want to go over these in a little bit more detail. One of the things here is why we ask you to do weekly questions and complete them. 3 to the x equals 27. You cannot, let me repeat that you cannot do something to this x to figure it out. You have to find common basis. 3 is already one of the smallest prime numbers, so therefore 3 to what power gives you 27? Use your calculator to figure that out. 3 to the third, and therefore x equals 3. In this one, this is a little more difficult. 27 to the x equals 1 over 9. Well, with this, what can we make 27? We can make 27 3 cubed. We already figured that out there. How do I bring the 9 back up to the numerator? Well, make it a negative exponent. So that really equals 9 to the negative 1. Well, still not common basis, so we'll go one step farther. 3 cubed equals 3 squared times negative 1. And now we're going to get 3 equals negative 2. Excuse me, got the x there, 3x. May help if we keep the x's. So 3x equals negative 2, and therefore x equals negative 2 over 3. So a lot going on here. Convert it from logarithm to exponential form. Get common basis. Know that a fraction creates a negative exponent, which is what we did here. There, and there. And then solve, since we have the same basis, we can set the exponents equal to each other and solve for x. With this one, we have 100 to the x equals 0.1. What we have to realize here is that 0.1 is really 1/10, which we can then state 10 to the 2x, because 100 is 10 squared, equals 10 to the negative 1. And since we have the same basis here, we get 2x equals negative 1 and x equals negative 1/2. So a lot going on. Pause, repeat, try to hear it again, see if that makes sense. This last one, 4 to what power equals 64? Well, we can either do it one of two ways. We can create this as 2 to the f of x, or 64, equals 2 to the 6, and then know that 2 times f of 64 equals 6, and we know that f of 64 has to equal 3. We could have done that, or we could have done 4 cubed. 4 to that equals 4 cubed, which is also 64. Okay? Pause again, see if you need to have it repeated, and then we'll go on to page 9. Switch gears a little bit here and do graphing logarithms. So here is graphing logarithms. It's actually much easier to graph logarithms than you think. You're going to hit the math button right here. You're going to actually scroll up. See how it says log base? Hit enter. And there it is. So in this case, you're going to do log base 3 of x. So 3 there. Scroll over x. Hit second graph. And that would have helped if I put in the y equals that. Let's try that again. Math up, log base 3 x. And you're going to notice here that it says graph on the interval of 1 to 8. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8. That's your x, that's your range, or your domain, 1 to 8. Your range, which is your y, is 0, 0.631, 1.3. I'm rounding just for time's sake. And 1.9. So that is your range. Your range is going to be from 0 to 1.9. I'm going to graph it now. You guys can graph it while you pause the video. And there it is, log base 3 of x. Okay, so now we're going to get into the main part of this lesson, which is page 10. So when you're ready, go to page 10. And so with this, I need you guys to take the time to read it and read through each one of these and see if you understand it. So please pause it. So, product rule. When you have the same basis and you multiply, what happens to the exponents? But you add. We've done that multiple times. Example, x to the third times x to the fifth equals x to the eighth. If you divide with the same basis, you subtract, and a power to a power, you multiply. The same, since logs give you the exponents, it's going to be the same idea. The log of base b of x times y is log of base b x plus log of base b of y. Those are added. When you divide, you subtract the logs, and when you have a power, the key here is that you can bring it out in front. You're multiplying it. So y times log base b of x. The key here is when you have a power, you can bring it out in front due to the power rule. That's going to be key. So add, subtract, and you can bring it out in front. So with that being said, these may look difficult. They do require some extra thought. I need you guys to try and think about it, or else you're not going to get this lesson. So let's look at this first one. Log base 3 of 9x. You notice we're multiplying, and therefore we can rewrite it as log base 3 of 9 plus log base 3 of x. So you sit there and say, is that an answer? And the answer is no. There's nothing that looks like that. So this can't be changed. That has to stay. But what does log base 3 of 9 mean? So we think to ourselves over here, 3 to what power equals 9? I said that a ton of the last class. And the answer is 2. 3 to the second equals 9, so it's 2. And now you look at it in 2 plus log base 3 of x. So again, product rule, we're multiplying, so we're going to add them. We have to evaluate. It's called evaluating this expression. So it's exactly what we did on the previous pages. And you get 2. Let's try this one. Log of x squared minus log of 1,000. Nope, none of them look like that. So what can we do with it? Oh, we see a power. Something erases something, so we can bring that out in front. 2 log of x minus, what is log of 1,000? We're going to evaluate it. 1,000, 10 to what power equals 1,000? Well, we know that's 3. Hey, there it is. Choice 1. Again, if you need to, pause this, think about it, or repeat it so you can hear it again. For this last one, this one's a little different, but a good question. We want it in log of 12. So our thought process is going to be, what expression using 3s and 2s equal 12? Well, I know 3 times 4 equals 12, but that's not using 3 and 2. So I can go 3 times 2 times 2 equals 12. Now we're using all 3s and 2s. So I'm going to say that log of 3 times 2 times 2 equals log of 12. That's a correct statement. And now I'm going to rewrite it. I see multiplication. So log of 3 plus log of 2 plus log of 2 equals log of 12. And I notice that I have 2 of those, so log of 3 plus 2 log of 2 equals log of 12. And therefore, do I see that somewhere? Nope, but I can do a's and b's. This is log 3, which is a, plus 2 log b, 2b, and there's a plus 2b right there. Another way you could have done that, just real quick, is 3 times 2 squared. You got log of 3 plus 2 log of 2 due to the power rule, bringing that out in front. Okay, let's go to page 11. So page 11, one of the last pages, you got 5 more exercises to go. We look at this one, and again, when we look at this, this is what needs to be going through your head. Quotient, therefore I'm going to subtract, and that this is really x to the 1/2. Anything square rooted is x to the 1/2. The power is 1, the root is 2. Power over root. I'm going to split it up. Log 2 of x to the 1/2 minus log base 2 of y to the 5th. I see these. And I sit there and go, none of those are my answers, so what can I do? Power and power. So I'm going to bring it out. 1/2 log base 2 of x minus 5 log base 2 of y. I go look, and do I have any of those? Yep, choice 3. So you're done. So again, you're always looking. Is it adding? Is it multiplying or dividing? And therefore you have to either make it the product or quotient rule. And is there a power after you did the product and quotient rule? And you can bring that out in front. Why don't you guys try 5 on your own and 6. Try both of those on your own. So pause this, try it, and then unpause it to see the answer. Alright, so let's talk about 5. 5, I hope that you guys got to this point. 1/2 log base 3 of 5 minus log base 3 of 27. Here it's again an evaluation. You evaluate it through to what power gives you 27. That's 3. So I would have been happy if you got to this part right here. The problem is that none of those answers actually looked like it. So when you look at these two answers, they both have a denominator of 2. You have to get common denominators. And so I have to multiply this by 2 over 2 to give me 6. So that's the reason why that one is. Now with this one, it's a little more difficult because we have a composition. We're taking g of x and we're plugging it into x. So I want you to rewrite it as f of g of x equals log of 100x cubed. Now pause it and try to do that one. So guys, I hope that you saw that you could split up 100 and x cubed. Log of 100, again, that's 10 to what power gives you 100? That's 2. Bring the 3 out in front, and you get 2 plus 3 log x. With this one, you have to realize that a square root is raised to the 1/2 power. We already talked about that in this video. You bring the 1/2 out in front. The key with this is that it's 1/2 of all of that. So the 1/2 stays out in front. You split up the 32 and x to the 7th. Again, I wrote over here, 2 to what power equals 32? 5. And so you get that answer. The last little bit here, I want to get this in before you can pause it to try to figure it out. But there is the last part. Hope you guys do well.